Section 2.5 is on solving linear inequalities. Now, linear inequalities are very similar to linear equations, except for our answer is actually going to be an interval. It's going to be a range of numbers. It's not just going to be one number. But solving them is essentially the same. If you look at the notes on the top of the worksheet, the major difference is the inequality rule, which is when you multiply or divide both sides of an inequality by a negative number, then you actually have to flip the inequality sign. So it's a very specific case. All of those things need to be taking place in order for you to have to reverse the inequality sign. So let's look at number one. We have a lot of work that we need to do here. If I subtract 5 from both sides, again, it's basically just like an equation. I have 2x is less than 12. And if I divide both sides by 2, then x is less than 6. So I've solved my inequality. Now I need to graph this on the number line. So I want to find 6, and because it's strictly less than 6, we actually don't want to include 6, which means it's going to be an open dot here. And because it's less than, I want to shade numbers that are less than 6. So 5 is less than 6, 4 is less than 6, the negative numbers are less than 6. So when I shade this, I'm shading to the left. And also, if you look at the inequality sign, when the x is on the left, this kind of looks like an arrow pointing to the direction that it's supposed to be. So as long as your x is on the left, you can kind of use this as a direction. So it points to the left, you can go to the left. If it had pointed to the right, you would go to the right. And then lastly, they want us to write this in interval notation. Now, interval notation is kind of a new notation, and it's used basically to describe what we've shaded here, what the region is. And we want to report two numbers. One is the leftmost part of the region, and one is the rightmost part of the region. So the leftmost number, it's not -8 because this keeps going. It's actually -infinity. So -infinity is our leftmost number. And I'm going to put parentheses around this. So we are going to need to choose between brackets and parentheses. I use parentheses if we can't include it. And we actually can never put a bracket around infinity because we can't reach infinity. So I want to use parentheses -infinity. And then I'm going to put a comma. And if I go all the way to the rightmost number, it's 6. So I'm going to put comma 6. And that's also going to be a parentheses. So this shaded region, the furthest left it goes is -infinity. The furthest right it goes is 6. Let's look at number 2. I want to solve this. So I want to distribute the -4. So -4x minus 8 is greater than 3x plus 20. And I need to solve for x, so I need to get my x's onto one side. I'm going to choose to move my x's to the left. So if I subtract 3x from both sides, then I'm going to get -7x minus 8 is greater than 20. If I add 8 to both sides, then -7x is greater than 28. And if I divide both sides by -7, which alarm should be going off because I've divided both sides by a negative number, that means I need to flip the sign. So let's not worry about the sign yet. Let's worry about what the number is. So this is going to be x. This is going to be negative 4. And instead of writing the sign like this, I want to flip it, and it's going to be written like that. So x is going to be less than negative 4. So on my number line, I'm going to find negative 4. Because it's strictly less than, I want to put a open dot. And because it's less than, I want to shade the numbers that are less than it. And then my interval notation, the leftmost number is going to be negative infinity. The rightmost number is negative 4. And they both have parentheses around them. Now, one issue with this is, or one reason why we need to flip the sign, is because when you're solving equations, it shouldn't really matter what side you move the x's to. So I do want to kind of do this problem again. So let's instead add, and you don't have to do the problem twice, I'm just doing this to show you. Let's add 4x to both sides. So if I do that, I have negative 8 is greater than 7x plus 20. Then if I subtract 20 from both sides, then this is going to be negative 28 is greater than 7x. And then if I divide both sides by 7, then I'm going to get x is less than negative 4. So you'll see that here I have this. If I go back to the other slide, I have that. They mean the same thing. So if you want to think about it as like the alligator eats the bigger number, there's my alligator. It's eating the negative 4. Here, the alligator is still eating the negative 4. And if I would not have flipped it on this route, then it would not be consistent with this. So we need to be consistent when we're solving these, and that's really why we have the inequality rule that you need to flip the sign, because you should be able to solve for x on both sides. So if you choose to move all your x's to the left versus if you choose to move all your x's to the right, you need to have the same answer. So that's really why we're doing that. Okay, lastly, let's look at number 3. So I want to add 2 to both sides. So 8x is greater than or equal to 16. And x, if I divide both sides by 8, x is greater than or equal to 2. So if I find my number line, this is going to be at 2, and this one's going to be a closed dot because my inequality sign is greater than or equal to. So if you see that line underneath, that means or equal to, meaning you need to include the number itself. Whereas on the other ones, it was strictly there was no line. It was strictly just that, which means it's everything up to, but not including 6. But back to our problem, this was including 2. And it's greater than, which means we want to shade to the right. And then in interval notation, we start with the leftmost number of the shaded region, which is 2. And we do want to include it, so it's going to be a bracket. So 2, comma, the rightmost number of the shaded region is infinity, because it's going to keep going. And we can never put a bracket around infinity, so it needs to be a parentheses. And that would be our answer.